Okay, so here we are going to find the proof for SSS congruency proof. So what is the meaning of SSS congruency proof? Here, let me explain the statement first. Two triangles are said to be congruent when three sides of one triangle is congruent or equals to respectively the corresponding three sides of another triangle. Let me repeat the statement. I mean, these two triangles are said to be congruent when three sides of this triangle is equals to respective three sides of another triangle. So this is the proof that we are going to do it here. So generally this proof, I mean, to prove this or to prove this SSS congruency, will take the help of SAS. Okay, what are we going to take? We are going to take the help of SAS because SAS is an axiom. Okay, and what do you mean by axiom? An axiom is a statement, okay, and which do not require any proof. So it is a self-proven statement, okay, which do not require any proof. So based on this SAS axiom, we are going to prove SSS congruency. And what is the whole broad idea to prove this? See, generally if you look at these two triangles, in these two triangles there cannot be, sides are equal, fine, but angles are not given. So when you do not give the angles, so to prove this, I mean, just with these two triangles we cannot prove the congruency. So what you need to do is we need an extra construction, so that we are going to construct here. So right, so to prove any theorem there is a procedure. First we need to write given, and next we need to write what we need to prove, and if any construction is required we can write the construction, and lastly we'll explain the proof. Okay, so this is the procedure to prove any theorem. What do you mean by theorem? Theorem means a statement. Okay, uh, a statement will become theorem only when you prove mathematically or only when you prove logically. If you prove any of the statement with some logic or some by deductive reasoning or any mathematical concept, then the theorem is going to become what? Statement is going to become theorem and it is going to become true. So then we can call it as theorem. So it is not just a simply a statement, but it is also a theorem. So when you can say theorem, you have a proof for it or we can prove it. Okay, so to prove this, what I am going to do is, see, I told you already, you cannot prove these two triangles congruent without another supporting triangle, because to prove these two triangles congruent, okay, we need to take the help of SAS axiom. And to prove, I mean, to take the help of SAS axiom, so one of the angle must be same. Of course, here two sides are equal, but angle is not equal. So therefore, to get the support or to get that angle equal, so I am constructing another triangle. So here first what I am going to construct is, see, already we know that these two triangles are dimensions ABC and PQR, where AB corresponding side is PQ and they are equal, BC corresponding side is QR and they are equal, and CA corresponding side is RP and they are also equal, which is given in the question. What exactly we need to prove? We need to prove triangle ABC is congruent to triangle PQR. So this is what we need to prove. What do you mean by that? Okay, here the sides are not going to be, I mean, if for example, if two shapes are going to be congruent only when the sides are equal, we can't say it. Their angles, their corresponding angles also must be equal. So therefore we need to make that angles also equal. Okay, so to get that or to do that, what I am going to do is, I told you we need to take the help of another triangle. So I am going to construct another triangle in such a way that, okay, so I am going to construct a QWR triangle. Okay, I am going to construct a new triangle QWR or RQW in such a way that, okay, where QW is equals to AB. I am constructing a triangle in what way? Where QW is equals to what? AB. And angle B is equals to, okay, angle B is equals to angle Q. So this is how I am constructing a triangle, or I am constructing a QW. So after that we need to join this Q and R. Okay, so let's start the proof now. So how can we start that? Okay, so first the broad idea I would like to give. First I would like to prove these two triangles congruent. Which triangle? ABC and WQR. So these two triangles I wanted to make congruent, and later I would like to prove, or I would like to prove these two triangles congruent. WQR is congruent to PQR. So automatically, if this triangle is congruent to this one and this triangle is congruent to this one, then automatically these two triangles are also going to be, these two triangles are also going to be congruent according to a transitive property. Okay, if A is equals to B and B is equals to C, then A is equals to C. So that's how we can prove these two triangles congruent, and this is the broad idea of proving this. Okay, so now let's start the proof. So first, what is our idea? So what is our, high focus? We need to prove these two triangles congruent. So let's see, is it possible to prove these triangles congruent? Yes. So here AB and QW are equal because we are constructing QW in such a way that QW is equals to AB. Next. And we are also constructing angle Q in such a way that, angle RQW in such a way that it is equals to angle ABC. So that means these two angles are equal. And we know that BC is equals to QR, BC is equals to QR, which is given in the question itself. So therefore these two sides are also equal. Now let's observe once again. This side is equals to, this side is equal to this side, this angle is equal to this angle, this side is equal to this side. By SSS axiom, these two triangles are congruent. Okay, so let me write that steps, explanation in the steps. Okay, so the same explanation I'm just writing here. So I'm going to consider two triangles, triangle ABC and triangle WQR. So where AB is equals to QW, because we are constructing by construction. Okay, we are constructing QW in such a way that QW is equals to AB. Next, we are angle B is equals to angle Q, because that is also by construction. We are constructing angle Q in such a way that which is equals to angle B. And lastly, BC is equals to QR. Okay, so BC is equals to QR because BC is equal to QR is given in the question. So therefore, by SSS congruency criterion, we can say triangle ABC is congruent to triangle WQR. Here, angle B corresponding is angle Q, angle C corresponding is angle R, and angle A corresponding is angle W. Okay, if you don't understand, you can take like this. Here, QR and BC are equal sides. When you take BC and QR, what is the opposite side of BC? A. What is the opposite side of QR? W. That means angle A and angle W are corresponding and they are equal. Because when you are writing a congruency, the order is very important. So to understand the order, okay, I am just giving that example. Okay, BC and QR are equal. So BC opposite is A, QR opposite is W, because BC and QR are equal. Next, and what is the other way? And we already know that angle B is equal to angle Q. That means B corresponding is Q. So C corresponding is R. Okay, sorry. A corresponding is W. C corresponding is R. Angle B corresponding is Q. So they are congruent. So our first task is done. Okay, let me close this. We are going to use this statement again. Now, what do you mean by the two triangles? These two triangles are congruent, which means to say that, okay, angle A is, this angle is equals to what? This angle, angle A is equals to angle W, and angle C is equals to what? Angle R. That is what the meaning of it. Okay, right. Next, what is the other thing? Not only that, AB is equals to QR. Now BC corresponding is QR. Now CA corresponding is what? WR. So therefore even this is also going to be equal. Okay, so this thing is also going to be equal. Once again, AB corresponding is QW, they are equal. BC corresponding is QR, they are equal. And next CA corresponding is what? RW. So RW, they are also equal. That is what the meaning of these two triangles are congruent. Okay, so let's by using these two statements, now I am going to prove these two triangles congruent. Okay, let's wait. Right. Now we said these two triangles are congruent. So once these two triangles are congruent, by CPCT what we can write? AB is equals to QW, BC is equals to QR, CA is equals to RW. CA is equals to RW. Not just that. Okay, the corresponding angles also equal. These are corresponding sides, they are equal. Corresponding angles also equal. Angle A corresponding is angle W, they are equal because A corresponding is W, B corresponding is Q, C corresponding is R. Angle A is equal to angle W. Okay, so angle W we can write simply angle W, but I wrote QWR. Okay, you can write simply angle W also because it's not creating any confusion. Okay, right, let me write QWR. Yeah. Next, angle B is equals to, what is angle B? Angle B is equal to angle Q, but Q means this creates a confusion, ambiguity. So therefore I can write angle RQW, and angle C is equals to angle QRW, this angle. Okay, so now what is the second target? First target is we need to prove these two congruent, and the second target is we need to prove these two triangles congruent. Okay, this triangle and this triangle we need to prove congruent. So how can we prove that? Okay, to prove that, okay, I need another support, another extra construction. What is that construction? Join P and W. I'll tell you why we are joining P and W. Because see, if you observe these two things, okay, there will not be any angle, because if you wanted to prove this, I have to use the SSS axiom. I need an angle, but in these two triangles there is no common angle and there is no angle. Here we have the angles, but in this triangle there are no angle. So to get that angles, or to create that angles, or to get that to form that angles, so I would like to join this P and W, which is going to help you a lot. Okay, just a second. Yeah, we joined already PW, so there we need to mention, in construction we need to mention that point, join PW. Right. Now if you observe carefully, okay, here we can see another triangle. What is a triangle? QPW. Can you tell me what kind of triangle it is? QPW. We know that PQ or QP is equals to QW. In a triangle, if two sides are equal, then their opposite angles are also going to be equal. So therefore, this angle, let us take this is angle 1. If I take this is angle 1, then this is also going to be angle 1. Correct? Why? Because these two sides are equal, therefore their opposite angles are going to be equal. And next, so here I am taking this triangle and I am explaining about this concept. Next, you go for other side, other triangle. What is that? RPW. You can see another triangle RPW, and if you observe closely, even PR is equals to RW. These two sides are equal. Here also we are getting an isosceles triangle. So in this isosceles triangle, these two sides are equal. So therefore their opposite angles are also going to be equal. So therefore the angle over here and the angle over here are going to be equal. If I write 2 here, here also I would like to write 2. So if you observe closely what is happening, something is useful or something you are getting. What is that? What is the angle W? Angle W is nothing but angle 1 plus angle 2. And if you observe at angle P, once again here also you are getting angle 1 plus angle 2. Correct? So therefore now observe these two triangles once again. What is that? The point that we wanted to get it, we got it here. How? Look at this one. Here angle W is equal to what? Angle 1 plus angle 2. Angle P is equals to what? Angle 1 plus angle 2. Now we already know that QW is equals to PQ. How? Why? Because AB is equals to PQ. AB is equals to PQ. This is given in the question. And after that, we are constructing AB is equal to QW. So if AB is equal to PQ, QW is equals to AB is equals to PQ, and QW is equal to PQ, then QW is also equals to PQ. That's a very obvious thing. Okay, right? So therefore, this side and this side is equal. Next, this angle, angle P is equals to angle W. Just now we proved it by using an isosceles triangle by joining this P and W. And next, lastly, we can see another one, that PR is equals to WR. So this side is equal to this side, this angle is equal to this angle, and this side is equal to this side. By SSS congruency, we can see these two triangles are congruent, and that is what we need to prove it. And we got it here. Okay. Okay. Right. So just now I explained the same thing. I am going to write it here. So what we have done, we have drawn PW. Why? Because we are getting an isosceles triangles, and using an isosceles triangles concept, we can make the angles equal. Look at this one. First I am going to take PQW triangle, where PQ is equal to QW. See, I am taking only this triangle. In these two triangles, these two sides are equal. When these two sides are equal, they are opposite angle. This angle, these two are going to be equal, which I am considering as angle 1, and this is angle 1. Next, take the other triangle RPW, where these two sides are equal, RP and RW are equal. So once again it is an isosceles triangle. So once again their opposite angles are going to be equal, which I am writing as angle 2 and angle 2. So together you can see here angle 1 plus angle 2. This is also angle 1 plus angle 2. So which I am writing here with the steps for writing. So this side, our ultimate objective, ultimate in the sense, the second target is we need to prove these two triangles congruent. Okay, to do that we are doing this all. So PQ is equals to QW. Angle P, that is angle P is nothing but what? Angle 1 plus angle 2 is equals to angle W, even because this is also angle 1 plus angle 2. Next, PR is equals to WR. So side, angle, side. By SSS congruency, we can see these two triangles are congruent. So now triangle WQR is congruent to triangle PQR. Now we already know that triangle ABC is congruent to triangle WQR. Now we proved triangle WQR is also congruent to triangle PQR. From transitive property, we can say that A is equal to, for example, assume triangle ABC is A, triangle WQR is B. So therefore this is also going to be B, and triangle PQR is going to be C. A is equal to B, B is equals to C, therefore A is equals to C. So 1 and 2, from 1 and 2 we can write triangle ABC is congruent to triangle PQR. So now that is what we need to prove it. Triangle ABC is congruent to triangle PQR. So this is how we can prove it. Okay, so it looks little complex. I don't think it is complex. The only thing is we must have the broad idea that what we are doing it and why we are doing it. When you know these things, when you know what is your target, what is your ultimate objective, or what exactly you wanted to prove and in what way we need to prove, then the things are going to become easy. Okay, so this is the proof for SSS congruency. Thank you. So my name is Suresh and I'm a maths teacher. Thank you for listening and thank you for helping. That's all.